let's say if I have gathered 7 people together, at least one of them have some repeated pin like 1717 or 2020, something like that as their pin, okay, based on this information. So that's what the at least one is, okay. Question with this at least one here. Is it a little bit easier second time around in terms of again, identify what probability they give you and find the probability of none by, again, take the not, the complement of what they give you, raise it to the power, okay? So question with the call warranty or the enter your pin question example here. Well, if you don't have a question, that is the end of 4.3, okay? So let's take a look at 4.4. So today, 4.4, let's take a look at 4.4 and then see how far we go. But 4.4 is very, compared, well, I cannot say very easy. The calculation is easy because your calculator can help you. The concept itself is a little bit troublesome. But let's take a look at this thing here, which is, again, the first thing in 4.4.4 is, again, 4.4 is the last item of chapter 4. And also a reminder that this Saturday, your chapter 4 test is due. Please, I saw, when I checked the test last time, I saw some of you guys wait until like 10 p.m. on Saturday to do your test. Make sure don't wait until that very last minute, because at 11:59 they will cut you off, okay? So again, they will shut you down, they will submit whatever that you have. So you know, you have enough time, but don't wait until the very last minutes where you don't have enough time to finish it. But anyway, there are 3 categories, not 3 categories, but there are 3 items in 4.4 that we need to take a look in terms of the fundamental principle of counting, permutation, and combination. The only thing later is they take the item that we learned in 4.4 and convert it with 4.1 and 4.2, which is probability, okay? But let's take a look at the fundamental principle of counting. So in short, this is basically tell you this. If you read this thing here, this is basically tell you that if we know the total of each group, if we know the total of the first group, the M, and if we know the total of the N group, to find the sequence of the 2 items, to know how many items mix and match together, all you need to do is multiply the 2 items. So for instance, if I were to ask you, if you go to this restaurant, right? If you go to your favorite restaurant and they offer 7 entrees and 5 different desserts, right? And all of them you like, right? You like the 7 entree and you like the 5 dessert, but you cannot eat all of them. So again, the question is, how many different ways can you go in there and order 1 entree and 1 dessert, right? So all you do is, again, we have 7 entree and 5 dessert. So all you need to do is take the 7 times the 5. There are 35 different ways that you can order 1 entree and 1 dessert. And that's what the fundamental principle of counting tell you is, all you do is, if we know the total of each group, or if we know the number of ways that we can perform them, all we need to do is multiply them together, okay? So if you look at the example 1, you say, wait a minute, Mr. Tran, you give me the easy example, but now the license plate is not what you just mentioned, right? So again, Louisiana license plates or license plates in Louisiana for compact call contain 3 letters followed by 3 digits. How many different license plates can be generated? Let's say that if we can repeat it, the letter and repeat it, the number, meaning your license plate can be AAA 3A111, right? So again, let's say that the repeated is allowed, right? You can repetition allow. So looking at this item here, the first thing is, same thing with your fundamental counting principle. In this case, you have to ask yourself is, how many slots? How many different slots do I have? How many different slots do I have to make up this license plate? right? Or how many different category do I have to make up whatever they ask me to make up? Do you agree that to make up this license plates, there are 6 different slots, right? And again, the fundamental counting principle is basically the first slot, time the second slot, time the third slot, time the fourth, time the fifth, time the sixth. That's what fundamental counting principle is, right? So looking at this thing here, the next question is, after you ask yourself how many different slots you have, the next question you need to ask yourself is, what is the total item can I choose to put in that slot, right? Last time we have 7 entree. The first slot for entree, we have 7 entree. And the second slot we have is dessert. We have 5 dessert, right? So we have 7 times 5. But in this case, do you agree that the digit is from 0 to 9, there are 10 single digits, 0, 1, 2, 3, 4, 5, 6, 7, and 9. There are 10 different single digits we have. And for the alphabet from A to Z, there are 26 letters in this alphabet, right? Which is, do you agree that this is my letter and this is my number, which is, again, I have letter, time letter, time letter, time number, time number, time number, which is in this case, everybody see that I have 26 times 26 times 26. Those are the 26 letter, or those are the letter slot that I can put in. And again, the number, the digit, I have 10 times 10 times 10, which is in this case, everybody see that if you multiply them out, 26 times 26 times 26 times 10 times 10 times 10, you have 17,576,000 different license plates. Okay, so again, this is your fundamental counting principle. And the most important thing about fundamental counting principle is you have to ask yourself, how many slots do I need? How many different slot do I need? And at each different slot, how many category or how many item can I put in there? Okay, and if you can recognize those, all you have to do is multiply. Okay, and the other thing that we have, and again, we will mention this in a little bit later, but let's take a look at the other two, and then we will attack the problem that we have, which is, again, the new notation we have is the factorial. N factorial, if you see N factorial, is basically tell you take that number, time 1 less, time 1 less, time 1 less, until you time to 1. Okay, so pretty much you try to put in term of you try to choose how many ways can you form something where you cannot repeat the item, right? Meaning, again, for instance, if you have 26 letter and I say you cannot repeat your letter, then again, you have to take 26 times 25, because once you use it, it's gone, which is 26 times 25 times 24 times 23, and so on and so forth, right? So the factorial here is basically how many ways can you choose something that you cannot repeat the item that you choose, okay? So that's what the factorial is. And the definition of 0 factorial, which is 0 factorial is always equal to 1, which is there is one way that you do not choose anything, which is you cannot choose it, right? So again, looking at this thing here, the other two things we have, which is this is your item, ladies and gentlemen. This is your main thing in terms of 4.4. This is your objective, or your the most important thing in 4.4 is this 2 item, which is permutation, which is you have to ask yourself in permutation, meaning, again, where the order matter. You try to arrange something, you try to put something in order, and the order make it different, okay? If the order matter, we have to use permutation. If the order does not matter, then we use combination, okay? And again, both way you still using, both way you still trying to arrange something. It's just that one way they have some position, which is first, second, third, or they have some title in terms of the actual name, in terms that they are important in terms of ranking. And the other one, if it's so general, they don't tell you any ranking, any order. They just tell you that you have this many, just pick that much. It doesn't matter what the order, then that's your combination, okay? And again, I don't focus into, the formula is there, but I don't focus in the formula because of the next thing that I will show you, which is this two item. The reason why I say this two item, the calculation is easy because your calculator can help you to calculate this thing here, which is, again, you can plug in your formula, your N and your R, which is, again, my advice, one advice is the N will always be bigger than the R. This is basically tell you that we have N item and we choose an R item, okay? So again, looking at this thing here, to work in your TI-83 or TI-84, this is what you need to do is you need to go to your PRB, which is, again, how do we get to PRB, which is, again, you have to type in math, scroll on top, scroll all over to PRB, and then once you choose the BRB, then there are option 2, which is the factorial, option 3, which is the permutation, and option 4, which is a combination, okay? Let me share you something else. So again, looking at this thing here, which is, again, reminder, the other last item is your permutation, the order matter, your combination, the order doesn't matter, and that is very important, ladies and gentlemen. So looking at this thing here, this is what I asked you guys to do, and let's do this thing here in terms of evaluate the following, right? So they ask you to evaluate 21 factorial, 17 choosing 9, you have 17 items or 17 people, and you need to choose 9 of them where the orders matter for permutation, and you still have 17 people and you choose 9 where the order does not matter. Again, the N is 17, the R is the 9, which is the N is the total, the R is how many are we choosing, okay? And again, the N will always be bigger than the R. So looking at this thing here, if you look at this item, which is, again, hopefully you guys see the calculator here, right? So looking at this, if I do this, you won't see the problem. Give me one, sorry. This is fine. So if you do this thing here, if you work on the A, again, I have the answer there, but if you work on A, you have to type 21, and then you hit math, which is math is right here. You go over to PRB, which is PRB. Your factorial is option 4. So this one here is different. I think the 84, your factorial is first, and the NPR is second, and the NCR is third. But again, this one here, the factorial is option 4. So you have to go down to option 4 and press enter, which is, again, 21 factorial. And then you press enter, you should have 5.10909 to the 19 power, meaning, again, 19 power, meaning you move the decimal 19 times to the right, okay? And if you want to do B, you have to type 17 first. You have to type 17 first, and then you go in PRB, and you use the NPR, which is the NPR, and then you type in 9. So again, to write this thing here for B, everybody see that I have to type 17, NPR 9. And then once you have that, you press enter, which is, again, how big is this? 8,821,612,800, right? That's how many different ways that you can choose 9 items out of 17. Okay, and again, similarly, if you take an 17 map PRB and go down to NCR, and then you press 9, which is, again, this is what you have, which is 24,310. One thing is, if the order doesn't matter, which is your combination will always be less than your permutation. The order matter, you have more way to do it in terms of that, which is, again, basically is 17 times 16 times 15 times 9 slot. Okay, but again, question with this 3 item here, and like,
sorry.
Yes, go ahead.
Can you redo the example again on the calculator from how you got 21? I'm on my calculator right now, so
you just press 21. You just press 21 and hit math, and scroll over to the right to the PRP right here.
Mm-hmm.
And then go down to the factorial, which is the explanation mark right here. For me, it's number 4. For you, maybe number 2.
Okay.
Yeah. I think if you have an 84, I think 84, number 2, option 2 is the explanation mark. Then you press enter, and then you press enter again.
Okay, so I got the first number, 5.109, but how did you get 17?
Not 17, not 19. E to the 19 right here.
Oh, okay.
Com 10 to the 19, which is E, which is basically tell you that is raised to the 19 power. In terms that not raised to the 19 power is 10 raised to the 19 power, meaning you move the decimal 19 times. Okay.
E is for exponent.
What's that?
E is for exponent.
Yeah. You have to write in your Connect Math. If it's big, they will tell you to write in scientific notation. So scientific notation is 10 to the whatever the E is, that's the power of the 10. Basically tell you that put 19 0 after the decimal, or you have to move the decimal 19 places to the right.
So then for the 17, you just typed in 17, then math.
Right. And then you choose NP or NCR, depend on if it's combination or permutation, and then you press 9.
Oh, okay.
Okay.
Got it. Thank you.
No problem. All right. And as you can see, the problem is not this easy, right? Nothing in math, right? In statistics, they give you the easy one, build up your confidence, right? Again, this is, the idea, right? The calculation is that. But this is your problem, ladies and gentlemen. Right, this is your problem, and that's what statistic is, right? They give you all this word problem, and that's the main thing that a lot of students kind of dislike it because of a lot of try to analyze the problem itself. But anyway, let's take a look at this thing here, which is, again, let's see what the story given us and what kind of information can we gather, right? So they say in a heart racing, one can make a trifecta bet by specifically specify which horse will come first, will come second, and will come in third in the correct order. So the trifecta, you have to put them, or you have to pick them in specific order, right? So again, it has to be exactly first, exactly second, and exactly third, correct order. One can make a box trifecta bet by specify which 3 horses come in first, second, and third without the order, right? So looking at this thing here, as you can see, trifecta, the order matter, agree? Because it has to come a correct order, which is the order matter. And the box trifecta, the order doesn't matter, because any 3 horses come in first, second, and third, you will win, right? So everybody see that looking at this thing here, we know that trifecta, specific order, the order matter. So therefore, we know that the trifecta will be permutation. For a box trifecta, the order doesn't matter, right? We only need 3 horses, and as long as those 3 horses come in, we would win the box trifecta. Doesn't matter first, second, or third, right? So looking at this thing here, for A, they say in a 10-horse field, how many different ways can you make a trifecta bet, right? How many different ways can you make a trifecta bet? So any problem from here on out, or later on, you will see chapter 5, chapter 6, and everything else. The first thing you want to ask yourself is, what is the total, right? In this case, do you agree that the total, how many horses do I have in this race? I have 10. How many am I choosing, which is, do you see that the N is the total, which is I have 10 horses in this field. The R is 3 because I need to choose 3 of them, first, second, and third, a trifecta, right? So again, looking at this thing here, do you agree that looking at this item, we have 10P3? Why 10P3? Because the order matter. And because the order matter, I have to use permutation. And if you recognize that the order matter and this permutation, now your calculator can do the work for you, right? You have to type in 10 NPR, which is, and then 3, and then press enter. And if you do that, again, the calculation, like I mentioned in chapter 4.4, the calculation, your calculator can handle it for you. But you have to know what to type in your calculator. You have to know the difference between NCR versus NPR, right?
The confusing thing about the question, it says 10 horse field, but it doesn't actually say. That got me confused because it doesn't technically say 10 horses are in the race.
Right. 10 horse field meaning there are 10 horses in the race.
Okay.
In this particular race. On your homework, they might spell out a little bit different. And again, the next problem you will see that they probably spell out a little bit different. This one here, I guess they try to keep it with the bed and horse language. So they tell you 10 horse field. But again, they can say there are 10 horse in this race, right? And then no, that's the same. It's just, I guess, instead of writing that long.
Right. Because I'm not familiar with the term. That's probably
Yeah.
what got me confused.
Yeah. So pretty much it's the same as say there are 10 horse in this race. Instead of writing that, they write a 10 horse field. But anyway, but we have and again, if you look at the question, they only give us 3 places, right? First, second, and third, meaning we know that we have to choose 3 items, that's your all. Agree? So looking at this thing here, now you have to know what the total, the only thing we have left, which is again, there's no other number except the 10 horse. But again, the next problem hopefully is a little bit clearer in that sense. So looking at this thing here, they tell you in the 10 horse field, how many different ways can you make a box trifecta bet? Which is again, same thing go, right? We have 10C3, why 10C3? Because the box trifecta the order doesn't matter. As long as the right 3 horse that you choose come in, you win, right? Or in this case, the order of the 3 horse that you choose doesn't matter, right? So that's why it's a combination. So in this case, again, once you recognize that it's combination, your calculator can do the rest. So that's why first of all, any question in terms of using the calculator. So 4.4 along with the other one, calculator are very heavily dependent, right?
Excuse me,
Yes.
Mr. Chen, may you explain like how could you know that is matter or does not matter?
Because right here they tell you for this particular problem, they tell you that you have to choose the come in first, come in second, and come in third, and the order have to be correct. Meaning again, whatever horse you choose come first have to come in first. Whatever horse come in second have to come in second, and whatever third horse come in, that particular order have to be a correct order. And this for the box trifecta, they tell you without specific order, right? So it doesn't matter which, any order. Maybe let's take a look at the next one. I guess I should do the other one. Let's take a look at this next one, and then maybe this one here have a easier. I just copied this from the book, so I figure let me try the other one and then try this one. But maybe this one is a little bit easier to look at, right? So a certain ice cream Polo offer 15 flavor of ice cream, right? So again, we know that, again, what is this 15 flavor? We know that is our total, right? We have 15 different flavor ice cream. You want an ice cream cone with 4 scoop. So again, everybody see that we have 15 and we choosing 4 scoop, 4 flavor of ice cream, right? All different flavor. So again, there are 15 different flavor and you want to choose all 4 different flavor. Now the question is, in how many ways can you choose a cone if the order of a flavor does not matter? So as you can see, looking at this problem is spelled out for you guys, right? So looking at this thing here, number one, do you agree that because the order does not matter, we use an A combination, right? Which is looking at this thing here, we know that the total is 15 and we need to choose 4, right? And this is what I told you guys last time, that if you have two numbers, one big and one small, your total will always be the bigger number. Why? Because there's no way you can choose 15 if you have only 4, right? You have to choose